Hi, 5th grade. Today we're going to be doing Module 3, Lesson 2, and we're going to be talking about number lines, and we're going to use these number lines to help us add up our fractions. So with our fractions, we have a lot of different ways that we can look at these problems as we try to add them. There's the typical just adding fractions with fractions that you'll probably see a lot in your workbooks, but there's also the unit form that we can look at. So I can look at 1/3 plus 1/3 and solve from there. So this is very similar to what we learned about when we were adding decimals. We can also think about these problems as multiplication. I could think of this as 2 times 1/3, or 2 groups of 1/3 equals what? We can also show this problem on a number line to help us figure out why 1/3 plus 1/3 equals what it does. So let's go ahead and get started with the number line. And you should be following along with me on your own number line. So right now we are going to be splitting our number line up because it starts right now from 0 and it goes all the way to 1. And usually your number lines are going to go from 0 to 1. For this problem, since my denominator is 3, that lets me know that my line needs to be split into thirds. So what I'm going to do is I'm going to skip count by thirds until I get to 1. So to do this, I know that 0, if I were to write it as a fraction, would just equal 0/3. So 0/3 plus 1/3 would give me 1/3. And then after that, I need to continue cutting up my line. So I have 1/3, I have 2/3, and then at the very end of my number line, I have 3/3. So your number line should look something like this. And you can even see the pattern in the numerator, 0, 1, 2, 3. So you can see that our numerator is going up by 1, but my denominator is staying the same. Now, to show 1/3 plus 1/3, what I need to do is I kind of need to jump on my number line. So I'm going to start my first jump from 0 to 1/3 because that is where I'm starting at 1/3, and then I have to add another third. So I need to count one more space ahead on my number line. So I do 1/3 plus 1/3. So we have 1/3, 1/3, and that gives me 2/3. So 2/3 is my final answer because I don't need to add anything else. And like I said before, there are other ways we can think about the answers to these problems. The number line just kind of helps us see what is going on. So if I have 1/3 plus 1/3 in unit form, I can think of this as 1 plus 1, which is 2, and then my unit will stay the same, which is thirds. So we have 2/3 here. I can also think of this as multiplication. And if I were to think of this problem as multiplication, if you remember how to multiply fractions, you know that most whole numbers have an invisible 1 underneath them. And when you multiply fractions, you usually just go straight across. So 2 times 1 is 2, and 1 times 3 is 3. That is not always going to work, but for this case it will. Now, let's move on to number 2. Number 2 is a little bit trickier because now I'm going to be adding fourths, or 3 groups of 1/4. So I have a fourth plus a fourth plus a fourth. So I'm going to show how to add this on my number line. Since my denominator is 4, I need to split my line into fourths. So just like we did last time, I'm going to start with 0/4, and then I'm going to start skip counting by fourths from there. So I'll have 1/4, where I know that 0 plus 1 is just 1, so that's why I have 1/4. Halfway, we'll have 2/4. Then I'll have 3/4, and finally, I'll have 4/4 at 1. So my number line has been kind of divvied up, and now I need to add by fourths. And again, you can see that progression as 0, 1, 2, 3, 4, but my denominator is staying the same. So now we have to add by fourths. I'm starting with a fourth, so I'm going to jump ahead to that fourth right there. And then I'm going to add 1/4. So I jump ahead one space to show that I'm adding a fourth, but I need to do that one more time because I have another fourth that I need to add. So I jump ahead one more time to get my answer of 3/4. And we can also look at my addition problem right here, because I know that when I add fractions, my denominator does not change. So it's going to stay 4, but I can also add up the numerators then, since my denominators have the same term. So I have 1 plus 1 plus 1, which equals 3. Remember, we're using the number line to show us why this answer is 3/4. And also, with my multiplication problem, remember those whole numbers usually have an invisible number 1 underneath them, and I just go straight across then. So 3 times 1 is 3, and 1 times 4 is 4, which gives me again my answer of 3/4. So let's take a look at this next problem now, and for this one I labeled the number line for you because this one's going to be a little bit trickier for us, because now instead of just adding 1/8, I now have to add 2 groups of 3/8 and then I add 1/8. So it's going to be a little bit different for us. So what I want to start off with is I already have my number line kind of divided up. I split it into eighths. So over here we have 0/8, over here we have 8/8, and then I counted up to 8. And you can see I have 0, 1, 2, 3, 4, 5, 6, 7, 8 in my numerators, and then my denominator stays the same. So now what we need to do is we need to find a spot to start in a number line. So I'm going to start at 3/8 because that's my first number in my addition problem. So I'm going to jump ahead to 3/8, which is right here on my number line. But I need to add another 3/8. So since I'm adding another 3/8, that means that I need to move an extra 3 spaces. So this number up here, the numerator tells me how many spaces I need to move. So if I'm moving 3/8, I need to go ahead 1, 2, 3 spaces. And I can even tell by the numerators that I moved ahead 3 spaces. So you can see that a 3 plus 3 is 6. And I can see that I go 1, 2, 3 spaces ahead to get to that 6. Now I still need to add 1/8 though. And since there's only a 1 in my numerator, I only need to jump ahead 1 space on my number line. And you can see that since I have nothing left to add, my final answer is going to be 7/8. Again, my denominator is not changing. And I can also find the answer by just adding up my numerators as well. So I have 3 plus 3, which is 6, just like we had here, 6/8. And then add 1 more, and I get 7 for 7/8. You are going to see some problems in your problem set that are going to say 2 times 3/8 plus 1/8, or some sort of problem similar to this. Don't get confused by that. All this is saying is that you have 2 groups of 3/8. So you have 3/8 plus 3/8. So whatever number is here is how many times you're adding this fraction together. So don't let that confuse you. It's exactly like this, just a different way of showing it. So now we're going to get into some really tricky problems, because now I have fractions that are going to be greater than 1. So right here we have a whole lot going on, but basically what this is showing me is that this addition problem, 2 halves plus 2 halves plus 2 halves, equals 6 halves, or 6 halves is the same as 3. I could also write this problem as 3 groups of 2 halves. I'm going to show what this also looks like on my number line. So you can see that I started off with 0 or 0 halves, since that's my denominator. And then at the very end of my number line, I wrote 6 halves, because that is what my answer is. So I'm going to try to figure out how I can get to 6 halves on my number line. When I am dividing up my number line, just like I did with the previous problem, since my denominator is 2, I want to split my line into halves. Except the difference now is I'm not just going to split my line into half like I would and just count 0, 1 half, 2 halves. I have to figure out how I can split my line into halves and get all the way to 6 halves. So to do that, I know I start at 0 halves, and then I'm going to add 1 half. 0 halves plus 1 half would just give me 1 half. And then I'm just going to go ahead just a little bit more and show 2 halves, because I have 0, 1, 2. So 2 halves is also the same thing as 1. So I'm going to put this whole number up on top just to show you that this is 1, because I know that 2 halves makes 1 whole. So our number line does not always have to be just 0 to 1. Our number line can go past 1 and keep going. It's just going to be a little bit more difficult for us to make. So when I continue making my number line, I'm going to continue splitting it into halves. But what I'm going to do is I'm going to be writing what's called an improper fraction. And improper fractions have a larger numerator on top and the denominator is smaller. So I have 0, 1, 2. What do you think is going to come next? Well, we have 3 halves now. So I have 0, 1, 2, 3. And then I'll have 4 halves next, because I have 0, 1, 2, 3, 4, but my denominator is staying the same. And 4 halves is the same as 2. And you might be a little bit confused because you don't completely understand, possibly, that a half plus a half equals a whole. So you can also think of these fractions as like little mini division problems, because this line right here that you see is kind of like a division line. So 2 divided by 2 equals 1. So 4 divided by 2 equals 2. So you can also think of your fractions as these little mini division problems, and that can help you figure out where the whole numbers are at in your line. Now my number line is going to look a little silly because I should have spread my halves out a little bit more to get to 6 halves. So I'm going to have 5 halves next, and usually you want your number lines to try and be as equal as possible. So I have 5 halves next, and at 5 halves, I will then go ahead an extra half, and then that will give me the 6 halves. And then what do you think the whole number will be above 6 halves? Well, I have 1 up here, 2 up here, so that will leave me with 3 over here. And I also can figure out that 6 divided by 2 is 3. So that is how we can show how to get the answer of 3 from the addition problem that they give us in an example. So I can move ahead 2 halves. So I start with 2 halves. I jump ahead 2 more halves to 4 halves. And then I can jump ahead again to 6 halves, and that is me showing my work on how 2 halves plus 2 halves plus 2 halves equals 6 halves. And you can also see that, remember, my denominator is not changing. I'm just adding my numerator. So I have 2 plus 2, which is 4, and 4 plus 2, which equals 6. And that is another way I can show my work. So let's move on to this next problem, and this is going to be our final problem. You are not going to have a you try problem, so just continue following along with me, and then you'll get started on your problem set. So 5th grade, for this one, I am again working with an improper fraction. I have the answer. I'm just kind of figuring out how to show that answer in a number line. So I have 8/5, and I have to again have my number line go past the number 1. So I kind of have most of your lines set up right now. We have 0/5 over here. I have something fifths over here. I want to try and figure out what my halfway point is. And then I have 10/5 over here. So I know that 10 divided by 5 is 2. So that means that the whole number over here is 2. So what do you think is halfway between 0 and 2? Well, I know that halfway between 0 and 2 would be 1. But what about the fraction now? So my fraction, I have 0/5 over here, blank fifths right here, and 10/5 right here. So what is halfway between 0 and 10? Well, I know halfway between 0 and 10 is 5. And I also know that 5/5 equals 1 whole. I'm going to split up the rest of my number line right now. So I'm just going to be counting by fifths until I fill up my whole number line. So I have 1/5, 2/5, 3/5, and 4/5. So we have 0, 1, 2, 3, 4, 5. What do you think is going to come next? we have 6/5, 7/5, 8/5, and 9/5, and finally 10/5. So you can see our number line is correctly separated now, and now I can show how to add up these two fractions together to get my answer of 8/5. So I'm going to start at 0 and then jump ahead to 5/5. So we have 5/5, but I still need to add 3/5. So I know that since my numerator is 3, I need to move ahead 3 spaces. So 1, 2, 3, I should be stopping at 8/5. And that is what my answer is supposed to be. Now, another way that we can write our answers, because for the most part, we really don't like writing our answers as improper fractions. So another way that I could write my answer is I could think about, well, what whole number did I just pass? Well, I just passed the 1. And if I were to pretend, or if I were to think about how many fifths I went past this whole number, I went past 1, 2, 3 fifths past that whole number. So my answer is actually, I could also say it as 1 and 3/5. And 1 and 3/5 is the same thing as 8/5. The only difference is that this is called a mixed number. So usually there is a whole number with a fraction, so that would be called a mixed number. And this is how we really like to write our fractions. And this over here is just an improper fraction. We'll continue talking about how to write these mixed numbers in a later lesson. And we'll also start figuring out how to show mixed numbers on our number lines as well. When you move on to your problem set today, I want you to be creating number lines for most of the problems, so make sure you're carefully reading the directions for those problems, and then we will start. I want you to find your answers. You can start with just the improper fractions, and if you think you can take on finding the mixed number, go ahead and try that as well. Good luck today, 5th grade, and if you need any help, please let me know.